Go. Good evening. This is a follow-up presentation to create AMCOR, an autonomous mobile Bluetooth control card.
We are Team HECF, and my name is Chester Soriano.
My name is Andrea Fabila.
And my name is Johnson Jaimes from the Mechatronics Class 4311, Split Section 040, instructed by Dr. Muad Salim from the Department of Mechanical Engineering at the University of Texas at Tyler. AMCOR is an autonomous mobile control obstacle avoiding robotic card using an Arduino. This project involves designing a robot car with autonomous and manual modes controlled by a cell phone via Bluetooth. This vehicle is powered or will be powered by an Arduino microcontroller, which will receive the control commands from the mobile app and drive the motors in the desired direction in manual mode. Also, it's going to work in autonomous mode where the car will detect the obstacles and move around accordingly. The prototype will have two ultrasonic sensors. The one on the front will be mounted on the servo that turns about 180 degrees and check for any obstacles to find a safe place or path to travel. And the rear side sensor will be glued to the chassis. Both of the sensors will avoid any obstacles in between to confront any collisions, whereas the buses will act as an indication.
Next up, we have the project objectives is to design autonomous mobile controlled obstacle avoiding robotic car using an Arduino that can be controlled via Bluetooth using a mobile app, manual mode, and autonomously in the other mode. The project objectives will be to design a robot car chassis that will be powered by two motors, integrate an Arduino microcontroller to control the motors, and then develop a mobile app that can communicate with the Arduino via Bluetooth. We also want to allow the user to control the car's direction and speed using the mobile app, and we want to implement obstacle detection and avoidance using the ultrasonic sensors while mounted onto the servo. We also want to kind of discuss what we have accomplished so far. So accomplished objectives, the following are specific objectives of the project that have been accomplished and are being modified at this time. We had developed a CAD prototype of the chassis model that the team has designed to house the electrical components that we will later see. We have developed an electrical schematics of the components needed to meet the project objectives that we will also see later in this PowerPoint. And then the Bluetooth control is being kind of discussed for now due to limitations of the components and not having an Android device to configure with the Bluetooth. So modifications to this idea might be needed.
The product deliverables will include the following: a functioning robotic car that can operate in two modes through a mobile phone using Bluetooth and anonymously, a mobile application that can communicate with the Arduino microcontroller to control the direction and speed of the robotic car. The wheels of the robotic car are controlled by a servo motor, which regulates the car's speed. Meanwhile, the ultrasonic sensor detects and avoids obstacles. A comprehensive project report that outlines the project's goals, approach, methodology, and outcomes.
This is the list of components. So we have the Arduino microcontroller, the motor driver, a Bluetooth module, the 4 DC motors, 2 ultrasonic sensors, pairs of jumper wires, female to male, male to female, and then 2 lithium-ion batteries, the mobile application, and then a 4-wheel drive chassis, a buzzer, a servo motor, and a button.
The methodology of the project includes the following: designing the chassis of the robotic car using SolidWorks and integrating the Arduino microcontroller, programming the Arduino microcontroller to receive signals from Bluetooth and control the motors of the robotic car, developing a mobile application that can communicate with Arduino via Bluetooth, testing the functionality of the robotic car in both anonymous and manual codes, as well as testing the app communication, integrating the servo motor, ultrasonic sensors, and programming the Arduino to detect and avoid obstacles, testing the functionality of the final system and making necessary improvements. Additionally, The system will be powered by 7.4-volt lithium-ion cells battery with a total capacity of 4 amperes, resulting in a power capacity of 29.6 watts.
Well, here we have the SolidWorks, the computer-aided design that we worked for this project. And we started by creating a chassis, which is the structural component that allows this robot to be mobile. And on this chassis, we're going to install 4 wheels. And this is pretty much the robot's frames that is going to provide a structure to attach the nano shield. As you see on the side of the chassis, there is a nano shield holders, and this is where all the components and the electrical systems and other design features will be held to manipulate the objects. And here we have some of the dimensions and the bottom part of the chassis, and we can see a couple of the holes that a couple of the motors or tires will be attached to, and as well as we can see the bottom parts of the nano shield holder with the dimensions, and it kind of like it has some triangular shapes that these triangular the chassis is gonna go inside these triangular shapes to get attached. That way we can attach all the nanos and all the list of components that we spoke about it later. And Chester will explain you the circuit diagram in the next slide that we also have created so far.
So this is the electrical wiring diagram that we have, and the list of components include the Arduino Nano microcontroller, which is the brain of the robotic car. It has 22 input-output pins in total. 14 of these pins are digital pins, and it has 8 analog pins. For the Bluetooth module, it's designed for transparent wireless serial connection setup. There's 2 ultrasonic sensor, which is able to detect obstacles and provides 2 centimeter to 400 centimeter non-contact measurement function. The ranging accuracy can reach to 3 millimeter. There's 1 servo motor, which controls the direction of the wheels. A motor driver allows speed and direction control of 2 DC motors at the same time. The module can drive DC motors that have a voltage between 5 to 35 volts with a peak current up to 2 amperes. There's 2 DC motors normally have just 2 leads, 1 positive and 1 negative. If you connect these 2 leads directly to a battery, the motor will rotate. If you switch the leads, the motor will rotate the opposite direction. And the power supply of the robotic car is by the 2 lithium battery.
And then right here, the team will be implementing a YouTube link at the end of the video. And then thank you so much for your time.
Thank you very much, Dr. Salim.
Thank you.